Hello everyone, and welcome. In this short video, I will walk you through a complete machine learning workflow applied to the combined cycle power plant dataset. My goal was to predict the net electrical power output of a plant based on environmental conditions such as temperature, pressure, humidity, and exhaust vacuum. Step 1. Machine learning approach and metrics. Since I wanted to predict a numerical value, I approached this as a supervised regression problem. To evaluate performance, I selected three key metrics: mean absolute error, or MAE, which shows the average prediction error in megawatts; root mean squared error, or RMSE, which penalizes larger errors more strongly; and finally, R squared, which explains how much of the variability in the data my model can capture. Step 2. Features and candidate algorithms. The features, or independent variables, I used in this project were ambient temperature, atmospheric pressure, relative humidity, and exhaust vacuum. The target variable was the net electrical power output. To solve the problem, I tested two algorithms: linear regression as a simple and interpretable baseline, and random forest regressor, a more robust model capable of capturing nonlinear relationships. Step 3. Validation and model comparison. I split the data into training and testing sets, using 80% for training and 20% for testing. To make the evaluation more robust, I applied cross-validation, ensuring that the performance was consistent across different splits of the dataset. The linear regression achieved an R squared of about 0.93, with an average error of 3.6 megawatts. The random forest performed even better, reaching an R squared of 0.96, with a much lower average error of just 2.3 megawatts. Step 4. Final model evaluation. Based on these results, I selected the random forest regressor as my final model. It showed lower errors and higher explanatory power, meaning it can predict the net power output with very high accuracy based only on environmental conditions. In conclusion, this project, I demonstrated a complete regression workflow in machine learning. I defined the problem and metrics, selected features and candidate algorithms, validated and compared different models, and finally, selected the one with the best performance. The random forest proved to be the most effective, while the linear regression provided a solid baseline for comparison. Thank you for watching, and see you next time.